All right, this is Algebra. We'll be starting Chapter 8. And in Chapter 8, we'll be graphing quadratic functions. We'll also graph quadratic functions in 8.1, but just your basic quadratic functions. So the first thing that you need to know is what a quadratic function is. In Chapter 7, we actually took a look at somewhat of quadratic functions. The polynomials make up your quadratic functions. So your quadratic function would look like y is equal to ax squared plus bx plus c. So for example, something like this, y is equal to 3x squared minus 4x plus 2. That's a quadratic function, and then we'll specifically graph that. I could have something as basic as just y is equal to x squared. When we graph our quadratic functions, since this is the most basic quadratic function that you can have, then this is what's referred to as like our parent function or the main function, because we'll compare all of the other graphs to this function right here. But on our first example, y equals 3x squared minus 4x plus 2, a is 3, b is negative 4, and then c is 2. On the second example here, a is 1, b is actually 0, and then c is 0 as well. And since we'll graph our quadratic functions, instead of y equals x squared, I can write it as f of x. Remember, that's function notation, is equal to x squared. And if I want to graph f of x is equal to x squared, first thing that I need to do is create a table. So to graph any quadratic function, we can create a table. I'm going to make a vertical table. I'm going to select values of x and then figure out the output, either f of x, or I could have labeled that y as well. So the values that I'm going to select for x, I'm going to select negative values, so negative 3, negative 2, negative 1, 0, and then positive values as well, 1, 2, and 3. So all of these are my inputs. I selected those. I'm going to substitute those back into the equation for x to figure out the value of f of x, the output. Again, I selected or picked the input values, and then I'm going to plug those in to figure out the output. So the first input is negative 3. So I'm trying to find f of negative 3, and that's equal to negative 3 in parentheses squared. If you forget the parentheses, it's not correct. Negative 3 squared is negative 3 times negative 3, so that's positive 9. That means when x is negative 3, f of x or y is equal to 9. The next number I'm going to input is negative 2. So it would look like this. Negative 2 squared would be negative 2 times negative 2, which is positive 4. And the input is negative 1. You're squaring negative 1, so it's negative 1 times negative 1, which is positive 1. F of 0 is 0 squared. 0 squared is just 0. And then the rest are pretty easy, I would think. F of 1 is 1 squared. 1 squared is 1. F of 2 is 2 squared is 4. And then 3 squared is 9. It would look like this. And then I'm going to put all of those points onto a graph. So I have the same table that I just created, but now I want to graph each of those points, just starting with the lowest value of x, negative 3, 9. So negative 3, positive 9 is in the second quadrant. I have negative 2, 4, also in the second quadrant, negative 1, 1. Second quadrant, 0, 0 is at the origin, 1, 1, 2, 4, and then 3, 9. So this graph actually is continuous, even though I didn't select any like decimal or fractional values. I could have, and it keeps going basically in each direction. It's more curved. I don't want to actually connect these with straight lines. It would look like this, and I do want arrows at the end. This is the graph of a quadratic function. So this is a graph of y equals x squared. Again, that's a quadratic function. There's a special name for this graph. It's like a U shape. The graph's name is a parabola. So the name of the graph of any quadratic function, so special has a specific name. It's called a parabola. And then there's specific parts of the parabola that are important. Right now, this is the lowest point on the graph. So where the two parts kind of meet is what's called the vertex of the graph. The graph is symmetrical, and what that means is the left side is like a mirror image of the right side. So right down the middle here is what's known as the axis of symmetry or the line of symmetry. Axis of symmetry actually always goes through the vertex, and it goes through the middle of the graph. If I were to fold this piece of paper over on the axis of symmetry and kind of just hold it up to the light, then the left side would be a mirror image of the right side. That's what the axis of symmetry is, or tells you on the graph. Okay, on the left side of the graph, from left to right, the graph is going down or decreasing, and then it goes up. So again, it's a U shape. It's increasing on one side. It's decreasing on the other side of the graph.